All right. Hey, everyone. Welcome back for another deep dive. You know we love to get into the nitty-gritty.
Absolutely.
And today we're building on something you might have just wrapped your heads around. Compound conditionals.
Ah, yes. The ands, the ors.
Exactly. We're taking that and leveling up to nested conditionals.
Multiple layers of decision-making. It's powerful stuff.
Definitely. And we're digging into some material straight from CMU CS Academy for this one.
Great resource.
So our mission today, making sure you really grasp these nested if statements, how they work, and when you might choose them over those compound conditionals we were just talking about. Ready to jump in?
Let's do it.
Okay, first up, the classic example. Imagine you've got a program where clicking on different parts of the screen, triggers different actions. Like visually, you've got these lines dividing it up.
Okay, I can picture that.
Now, look at this snippet of code.
Yes.
If by 200, and then right inside that, another if, part 200. What's going on here?
So the key is that second if, the one checking if y, is greater than 200. It only even gets a look if that first condition is met. Like if x actually is greater than 200.
I see.
Think of it as you need a key to open the main door, right? That's your x greater than 200. And only if that door swings open can you even see if there's another door behind it. That's your y condition.
Makes sense. So if that first door is locked, you're not even getting to that second check.
Nope, you're done right there.
So in this example, if both conditions are true, x is greater than 200 and y is greater than 200.
Then you get the action.
Yeah, the program draws a green circle and you get this message that pops up like, yes. And the cool thing is, the source even says, run the code and confirm this. And if you actually try it, you'll see that green circle and the yes only appear in the bottom right corner. That's where both those conditions are met.
Because that's where x and y are both big enough?
Exactly. But here's the thing. We could get that same result, that both things must be true behavior, using a compound conditional with and, right?
Right. You could just say if big 200 and big 200, one line, done.
And this is where checkpoint 1 comes in. The source asks, what's another way to make the program draw those circles only in the bottom right?
They give you options. Two separate ifs, sticking with a nested one.
But they're nudging you towards that compound conditional, right? Just combining the checks with an and?
Exactly.
Yeah.
Because it gets the same job done, and that's important to see. You often have multiple solutions in programming. Sometimes it's about picking the one that's clearest or maybe the most efficient.
Right. Interesting to think about which you'd use in different situations. Okay, so we've got the basics of nesting down. But what about when we introduce an else into the mix?
Oh, things get more interesting then. Definitely more options.
Okay, so example number 2. Inside that initial if by 200, we still have the if, degree 200, leading to the green circle. But now there's an else nested inside.
Ah, so now we've got a backup plan if that second condition isn't met.
Exactly. How does that change things?
So let's say x is greater than 200. Our first door's open, but y isn't big enough. We're not hitting that green circle anymore. Instead, that nested else kicks in.
And what happens?
Now you get an orange circle and it's labeled nope.
Nope. Huh. Okay, but here's something that tripped me up at first. If x itself is not greater than 200, if that very first if is false, we skip everything inside, right?
Absolutely. We don't even bother with the inner if or its else.
Which is why, in this example, those orange nope circles only show up on the right side of the screen.
Specifically top right, where x is big enough, but y is letting us down.
And the source even points this out, right? They tell you to run the code and think about why there's only one orange nope circle. It really makes you consider that specific condition.
Yeah, it's like a branching path. That first check determines what other possibilities you even get to explore. Okay, now for example 3.
All right, another example. And this one, it's all about the location of that else. We're still working with by 200, but the else is now outside that inner if.
Interesting. So it's still within that initial block, but linked directly to the x check.
Right. So how does moving that else change things?
Well, let's go through those possibilities again. If both x and y are greater than 200, we're still good. Green circle, bottom right, just like before.
Okay, that part's consistent. But what if x is greater than 200, but y isn't?
Now it gets interesting. We go inside the first if block. Y is too small, so the inner if is false. But there's no else attached to it directly anymore, so nothing happens.
So that top right quadrant, which used to have the orange circle, is now empty.
Empty, because that else isn't there to catch it anymore.
And what happens if x itself is less than or equal to 200?
Now that first if is false, so its alpha block takes over.
And that's where we draw the orange nope circle.
Exactly. But now Because it's linked to that outer if, we get those orange circles along the entire left side of the screen. Doesn't matter what y is anymore.
Wow. Just moving that one little else made a huge difference. It really shows how important the structure of your code is. It's not just about making it look neat. It directly affects how the program runs.
100%. You have to be precise with those ifs and elses, where they are, how they're nested.
Okay, now the source also touches on something else. Nesting ifs inside else blocks.
Ah, yes. Taking it to another level.
They give an example where you end up with the same result as that last one, orange on the left, green in the bottom right. But the logic is phrased differently. It's like, if x is not greater than 200, draw the orange. Otherwise, meaning if x is greater than 200, then check y and maybe draw the green. It's just a different way to arrange the same idea.
Precisely. And that brings us to checkpoint 3, which is all about choosing between these different approaches.
What's the takeaway there?
The source says, and it makes sense, use compound conditionals when you can, nested conditionals when you have to. But then they add this really important point. Use whatever seems clearest to you for that particular problem.
I love that. Sometimes a single line with an and or an or is so much easier to read than a bunch of nested ifs. But if you have a situation where one decision absolutely needs to happen before you even think about the next, then nesting might be the most straightforward way to do it.
It's about making your code understandable, both for yourself later and for anyone else who might need to look at it.
Okay, so to sum this all up, nested conditionals. They let us build these more complex decision-making flows in our code by putting if statements inside other ifs or even elses.
And that means certain checks only happen if a previous condition is true. It creates these dependencies.
We saw how that can lead to very specific outcomes based on multiple conditions, and also how crucial it is where you put those else statements within these nested structures.
Even small changes can make a big difference.
And of course, we touched on how nested conditionals compare to compound conditionals, and how the choice often comes down to clarity and the specific steps in your logic.
It's a great toolkit to have. Different ways to approach these problems.
So for you listening, think about it. How often do you make decisions in stages in real life, where one step only makes sense if a previous one went a certain way?
Lots of examples out there.
Exactly, and that's what nested if statements let you represent in your code. It's all about those pathways of possibilities.
Building logic that mirrors how we think.
That's it for this deep dive. Thanks for joining us.
Always a pleasure.